SwayamPrabha. Digital India. Educated India.
Welcome to the class of Design Practice for Intelligent Product Design. As I told you after the overview of design practice for some intelligent products, that we will start the foundation of how to carry out intelligent product design, and in that the first phase will be related to design concept generation. And how do we actually do this in practice for concept generation? Well, one of the very well reputed technique in that direction for design concept generation is called axiomatic design. And this is something which has been initially discovered by Professor N.P. Shu at Massachusetts Institute of Technology, and later on has been developed by many researchers, and it is one of the very established technique, which is what we are going to look into today. Now, before I go into these details, there is always a dilemma. This dilemma, as a designer, you may always have inside you. I also always face it, that is design art or design is science? Well, if you consider, let us say, form design, aesthetics is a very important part of form design. You know, some of the best products, right? The Apple computer, you would see that aesthetics plays a very important role in it. So, from the aesthetics perspective, there are some classical notions of form which symbolizes the beauty. So, that is a perspective which is important. Then there are also cultural perspectives, like every popular form tells us about some story, about the tradition of the place. For example, when we look at lotus, the lotus form reminds us about Buddha and Buddhist religion. Similarly, the form of pyramid reminds us as a group of people who are worshipping the celestial divine. And if there is another perspective called technical perspective, then that also is an important part in form design, which has to take care of the ergonomics of design, the physical properties of the design, as well as the visual properties of the design. So, even for the form design, not for the functionalities, there are different perspectives that goes inside a design. If I look at this particular urn or amphora or some kind of a container, well, this is one of the very ancient Grecian urn. If you look at it, it is having indeed some brilliant arts embedded in it. Look at the forms, look at the patterns that is there inside it, look at the color, look at the shape. Everything talks about aesthetics, but also there are different technical aspects that went inside the design of it, and in which you won't be able to deny that there was no science in it. Possibly the first important science that was there in it, that what will be the volume of this particular urn. Somebody has to think of that what it is going to contain, and hence the volume was of very important consideration. Again, what is the type of material it is supposed to hold? If it is supposed to hold only some grains, let us say some paddy or some wheat, then it is supposed to have some type of a surface property. On the other hand, if it is supposed to hold oil, let us say olive oil, then that oil should not react with the surface. So, the surface coating that is there deep inside, that is one thing that the potter must have thought of when the potter had actually put it into fire, and also how to handle this whole thing. This entire urn is, the very design of it is telling that it is to be held with 2 hands, which means it must be of weight which is something more than, let us say, 10 kg or 20 kg, and hence there is a provision of these 2 hands in both the sides in order to grip it properly. So, you see, so many science aspects are also there in the design of one of the systems which you can consider to be one of the most beautiful aesthetic product, over which people have even written poems. Like, you might have read this poem, Ode to a Grecian Urn. I will just quote a few lines. What leaf-fringed legend haunts about thy shape, of deities or mortals or of both, in temple or the dales of Arcady. So, that is something that goes inside. If you really think of the development of these Grecian urns, initially it used to also tell stories like victory of the style of Athens. Athens was the capital of Attica, and when they had the victory over the Corinths, then the Corinthian style went away and the Athens style started to gain. There will be reversal of styles as and when these winning or losing will take place. And one of the important thing of this Athens style is that they will be strictly observing the geometry to the extent of using rulers and compass. So, their manufacturing is also having lot of science in it, and there will be different designs for different types of urns like crater, kylix, amphora, and potters were renowned for ceramics and refractory technology. So, all these things are embedded inside. Now, there are some rudimentary technical perspectives that also becomes important for us when we start to design something, like minimizing the manufacturing cost, minimizing the space requirement, minimizing the weight, minimizing the losses, optimum handling, maximum rate of production. All these things goes inside when in your consideration when you will be designing a particular product. So, for a Grecian urn, this may not be apparent for you, but if you take one of the products like for which our laboratory is famous nationally, is the pipe health monitoring robot. It is developed in the SMSS laboratory, and you look at it, this robot, beauty of a creation, which is supposed to go inside a gas pipeline, completely passive driven by the flow. So many complex elements in it, and one by one, if I click, you will be able to actually see this pipe health monitoring robot with a weight of 16.4 kg, 1.25 meter of length, the wheels of nylon 66, the electronics battery for minimum sensors, and that is a lithium polymer ion battery of 2200 mAh power, and also microcontrollers. Now, if you look at it, it has a deflection system, one of the first technicality, because the gas is going to hit from that right hand side, and then you would see the speed controller. So, the deflector is propelled by the drag force. So, you have to think of it, what would be the size of it, and then there will be vanes there which will actually control the airflow. So, there are these vanes that will be there at 3 different spots that will control the airflow, bypass flow. As a result, the drag force will change. Then there will be a speed control system. It is a completely passive governor type speed control system, completely passive in nature, which extracts kinetic energy through transmission and just convert it to the hydraulic force. After the speed control comes the optical system sensing. So, it has the first level of eyes which actually senses at the infrared range. So, you can see that as the rays come, incident light IR, and it goes back. So, transmitter and receiver, we start to see whether there is crack there or not. And then the touch sensor, that is touching the undulations in the pipe, and then from that the touch sensor is trying to figure out whether there are corrosions in the pipe or not. And then magnetic flux sensor, that actually talks about that how much of magnetic flux leakage is taking place. Then the shock absorber system, that is there in case of a overspeeding robot. So, all these things together makes this complex system, and for designing of such a system, you cannot just like that do it unless there is a formal process of design. That is what brings us to today's concept of concept generation, and generally people use different types of techniques for concept generation, like brainstorming, like 6-3-5 method, which involves 6 members, 3 design solutions, and it is passed after 5 minutes, systematic form of brainstorming. Then Delphi, which involves written comments from experts in 3 stages, and then synectics based on the analogies, it is heavily practiced in NASA. But we are not going for any intuitive design, because clearly such a complex system, one of the examples of intelligent product, cannot be done intuitively. So, we have to do through a systematic study of physical process, and that systematic search could be either through design catalog or through axiomatic design. Design catalog is good when you already have certain products. If you do not have, like in this case this was the first of its category, then the design is to be based on certain basic axioms. That is what we had tried. So, the nature and need for systematic design is that the designer has to be a man of many parts, and he or she must aim at a dependable approach, encourage a problem of independent abstract approach, foster inventiveness, compatible with concepts, methods, and findings of other disciplines, that is needed. So, let us look into it, that what is the axiomatic design. So, first important thing is then what are the axioms. Axioms are truths that cannot be derived, but for which there are no counter examples or exceptions. And objective of axiomatic design is to establish a scientific basis for design based on logical and rational thought process and tools. So, most important thing is that when we will do an axiomatic design, we will consider the entire design as a mapping process. In the left side of the mapping process, we will always have what we want to do, and in the right side we will try to figure out that how we will be doing it. For example, we will start first with the customers, the necessity of the customers, that is the customer domain, and then from the customer domain necessity we have to map it to functional domain, and that is where you have to see that how you will do that mapping. Similarly, from the functional domain, if you have to go to the physical domain, so this is stage 1, 2, 3, third vertical, you have to again ask yourself what are the functions, how you are physically going to do it. And at the end of physical domain, you will go to the process domain where you are going to manufacture it. Again you have to ask what are the physicalities you want to integrate, and then you have to reply that question through the how. Naturally, when this how, and this how, all the 3 are done, you will automatically get your design of the system. So, mapping first from CA to functional domain, FR. Okay? Some people also call it as CN, all the same, that is customer need, and we call it as customer analysis. Now, the CA comes from 2 parts. One is called voice of customer, VOC, and another is called voice of business, VOB, what the business is talking about and what the customer is telling. So, we take the customer's definition of new product features, but there will be lot of linguistic uncertainty in it, lot of dichotomy. For example, a customer says I need a dream car which should be quiet, stylish, comfortable and easy to drive. How do you actually sort of explain it, that does the quiet means the vibration level below a certain, does the style means that certain type of a form, comfortable, what does it mean again, is it with respect to temperature or noise and vibration or humidity, it needs to be defined. Now then, once we do the need modeling, that is gathering and interpreting customer needs can be difficult without this need modeling. Sometimes we do it through the interviewing methods to establish a list of customer needs. Sometimes we go it to questionnaires and then create later on an affinity diagram and activity diagram. These are regular process of product design. Hence, I will not go into the details. You should look into any basic textbook of product design to look into these two terms. Now, linguistic inexactness in terms of the customer's point of view do affect the design. For example, how to aggregate qualities like and, or, etc. And we need to always put it in a 6-point scale, Likert scale: doubtful, slight chance, improbable, likely, good chance, fairly certain, all these things. And then we need to also see the MAD, that is mean absolute deviation between the geometric and arithmetic mean of the model. Now, let us do some simple exercises. You try design of a new digital calendar which should be cheap and innovative, and design of a perfect 3 days for the honeymooners. So, that means you have to do the customer analysis, like in the second case, what the customer wants: a weekend trip for recreation. Functional requirement, maybe no work pressure, pollution free environment, good security, and the design process from this may be mobile with filter, so that your boss's call do not arrive. Maybe it should be hilly resort, so that people cannot easily come and disturb. Maybe something with a private security. So, these are like the functional requirement talks about what should be the design process. Now, let us do one such analysis. Let us say we have to build an academic institute. So, who are our customers? Students, for example, prospective students. So, satisfaction of the students and their parents, and also we need lot of funds. So, the cash flow for teaching, research, R&D, and also we need some profit. Now, profit for an academic institution is always in terms of, let us say, better teaching paradigm, new invention, this type of things. Then growth, some visionary leadership has to be there, the institute has to grow. So, if that is our CA, what are our functional requirements? It has to be, this is an important point, minimum set of independent requirements. Okay? Functional requirements should be decoupled one from the other. I will call it as axiom 1 very soon. So, for example, one functional requirement could be from the customer satisfaction point of view, quality education and research. Another could be fund management. Another could be provide mentorship, and another could be innovation. So, these are functional requirements. Then I go to the physical domain, where I have to design. How do you ensure quality education? Well, you must have a undergraduate, PG, postgraduate written program, otherwise you cannot ensure. You must have a research organization for the second point, the research innovation. Then you must have to organize funding. So, you must have an institute for that, which we call Dean of Resource Planning and Generation. And then you must have new educational programs, cultural changes, exchanges, academic synods. So, these are all the design solutions to build up that particular customer satisfaction in the design domain. Next will be the process. In the physical domain, what is it that we need to do? Well, we need to exactly quantify the quality and quantity of student, the budget and quality support staff, the programs, the resource organization. So, this is how the design gets built up in the system. Let us take another one. Let us take a case study of design of a new depth charge initiator. This is a military requirement. Cost is a constraint here, let us say, and design a sensor system which ensures the initiator to send a signal to the detonator when the depth charge hits the target. That is most important. Customer says low cost, as I told you, simple working concept, that is also important from low cost point of view. CA need not be decoupled. More reliable working principle, because it has to work properly. Now then, if I look at the functional domain, what are the minimum set of independent requirements? One is initiation of the detonator, it has to work perfectly. And secondly, launching of the depth charge. Depth charge is a bomb that is generally launched from a ship. So, the launching has to be perfect for it. What are the physical domain? Well, one important thing is an electrical system or a mechanical launching system. You have to take a decision. Now, the moment you do that, what that system has to do? It has to provide force to launch the device, send the device in desired direction, convey force to entire device. So, these are the sub requirements of the force. Then you come to the design solutions, like how do you generate the force? Maybe through the barrel, explosive barrel, and design of a chassis, so that you do not get a shock. There are constraints in each of the designs, like in this case you get the constraints of weight, position of CG, dimension, safety, environmental duress, etc. If you explore each one of them, let us say FR1 is electric system, then FR11 could be provide electricity, activate all these three safety mechanisms, send ignition signal, battery, all these things will actually come into picture. And similarly, for the detonation, the gas pressure, presence of water, water pressure, impact on target, everything becomes important. Now, this FR and DP, one thing I said that they could be subdivided, right, like FR1 can have 1 1 1 2, DP1 can have 1 1 1 2, etc. Not only that, they are having a zigzag process, like you have DP1 2, it may affect DP1 1 and FR1 1 and 1 2, and same thing is true for DP1 1, which is going to affect 1 1 and 1 2. So, this zigzag process has to be kept into account. The FR and DP cannot be solved independently. What is the axiom 1 for us? Maintain the independence of the functional requirements. Functional requirements should not be coupled. Axiom 2, the minimization of the information content of the design. Best design corresponds to the highest probability of the success of FR, the functional requirements. Axiom 2 is also important to choose the best design. And you would see invariably it will have the sum of all the probabilities of success corresponding to each of the FRs. Now, why this sum is to be done? Well, it is very simple. If it is a joint probability, then instead of taking the probabilities product of it, we take the log of it, so that you can actually sum up it, because you know that product of a log is equivalent to summation of each one of the probabilities. And then we consider the summation either as reciprocal or as the negative sign, so that the highest probability will give us the minimum value of I, because it is the not the absolute scale, but with the negative value. So, that is how we would actually characterize the success of our design. Now, when you will do it, let us say I have 3 such FRs and 3 such design solutions, then that would mean that I am going to have a 3 by 3 matrix here, coupling these design solutions with FRs. Now, there are 3 possibilities of this matrix. One is that it is only diagonal, rest are all 0. This is what is uncoupled design, that is the best design. Another possibility is that it could be coupled, if it is coupled, then all the terms are sort of present. Another good possibility could be it is decoupled, which means it is like this triangular, where one part of the triangle is all 0, rests are actually having entries. So, that means you can still sort of uncouple it, but through some transformation. However, coupled you cannot do that. and it can be redundant also. That means you have more number of design solutions. Suppose instead of DP3, if you also have a DP4, then this would become what? It would become then 3 by 4. So, this would then become redundant. That means you have given additional design solution to solve the problem. Now, this is the example of a coupled problem, like a coupled FR, that hot and cold water, either you control the temperature or you control the flow, you will not get both, because it is a coupled solution. But if you go for today's solution, you can actually do the both. So, this design is a better design, the uncoupled design, than a coupled design. So, this is a better design. Just an example of how in the axiom stage itself, if you take care of it, it could be a better design. Second possibility is circular dependency, that is component A affects B, B affects C, but C affects A again, like the rear view mirror design of a car, that your vibration isolation is the perspective, you make the frame steep, increase the thickness is the design solution, and if I increase the thickness, the natural frequency will come down, which means there will be more vibration, it will suffer. So, this becomes circular dependency, and you have to be alert of that. Secondly, there will be some bias, there will be some variance, there will be some design range widening, which are the complexities that you have to take care of it. And it has been observed that if your design is uncoupled, then these problems will generally not come. Now, if you already have a design, you can actually measure the quality of the design also, like does it have any conceptual vulnerability, which is if it is violating any of the design axioms, or does it have any operational vulnerability. So, both from the point of view of whatever we have discussed will actually illuminate the axiomatic quality of the design, and that way you would be able to stay competitive. That is why it is so important that the design has to remain competitive, and also this design will be based on a set of clearly demarcated design principles and the deployment of quality methods during the design. That is how it will help us. You may ask me, sir, can we have new axioms in design? You have only talked about 2 axioms. Yes, you can. Of course, so far these are the 2 that people have generally found to be true. You can have a next one, but keep in mind the axioms are to be independent. You should not, your axiom should not get interfered with the first 2 axioms, and no axiom statement can be derived from any combination of the others. The axiom should be consistent also. It is not possible to deduce, if you find out any contradiction from the axiom, then it is no longer an axiom. An axiom set should be complete also. So, these are all important properties that are needed. So, I am giving you 2 problems for you to try your hands. One is develop a new product for home energy solution, which should be cheap, which can take care of the power requirement of a family member, family size 6 to 8, maximum duration 8 hours, and it is eco-friendly. Secondly, develop a new entertainment product, at least visual and sound based, which could be also considered as a status symbol and cost no bar in the second case. Try these 2 and try it in a manner that you should in each case identify at least 15 functional requirements, and with 3 level of it, FR1, 111 and 111. So, 3 levels. Try to do this, you will understand the complicacies of axiomatic design, and also that will illuminate your line of thinking. Thank you.